Okay. So when we are considering a similarity, that both these are the hardware description language. Now, what is mean by hardware description language?
Using this, we can implement any hardware.
The language which is used to describe a hardware, that is called as a hardware description language. That means using this we can describe any logic circuit. Okay, so that is a HDL. Now there are two HDLs that are widely used. That is, one is the Verilog and another one that is a VHDL. Okay. Now in most of the countries, in industries, okay, or instead of saying in most of the countries, in industries, Verilog is most preferred language. And but in academia, that means in educational institutions, we use VHDL as the hardware description language to describe digital logic circuits. Okay? So here, uh, in earlier in earlier sessions, we have discussed a lot about VHDL. Okay, so how to write programs using VHDL language, that we have discussed. Also, in earlier sessions, we have discussed about this Verilog models also. So, what are the basic things in Verilog? Then, how to write programs in Verilog, that we have discussed earlier. So, now we are going to revise again once more all these things. So we are going to discuss about this Verilog models. Okay, so in the yesterday's session, we have discussed what is Verilog language, then what is the history of this Verilog, then what is difference and what is the similarity between this Verilog and VHDL. Okay, so the one most important thing is that Verilog, that is used for the lower level designs, while this VHDL that is used for higher level designs. But remember that always whenever you are programming using Verilog, you have to remember that Verilog is a case sensitive language. Okay? VHDL is not case sensitive, so you can write a program in any case. But you have to remember that whenever you are writing program in Verilog, you need to consider a case and you have to use proper case for the your syntax, okay, or whatever keywords that you are using. Now all the keywords that are available in Verilog, that are used in a lowercase. Okay, so you have to use all the keywords in a lowercase, so that you have to remember. Now, this Verilog language, that is used mostly in North America, Asia, and Japan, while VHDL is used in Europe. Okay? So, this is the somewhat difference between the Verilog and VHDL. Now, uh, we were discussing about what is wires and then what are the different data types that are used in the Verilog. So let us once more times have discussion about wires. Okay. So now remember that in a Verilog there are two main data types. One is nets and another one that is a register. Okay. Now what is mean by net? Net is the data type that represent connection between things. That means if you want to connect two objects, then you use a net. Okay, so that is the data type that you are using in a Verilog. Now, one more thing about the net, that is they do not hold their value. Okay, so it is uh, uh, so they are just used to transfer the data, but they are not used uh, used to hold the values. Okay, so they take their value from a driver. It may be a gate or any other module, and then it transfer it to the another output signal or whatever may be the module. Okay? So these nets that cannot be assigned in an initial or always block. So now what is the initial block, what is the always block, that we are going to discuss afterwards. But we cannot assign these nets in a uh, initial block or the always block. Now registers, that is the another data type that is used to represent data storage. Okay, so this is the main difference between net and register, that nets cannot hold value, but registers are used to hold the value. That means they are exactly as the memory in a computer. Okay, so that means for that circuitry, registers will be used to store a data. So they are used to hold their value. Now, for how much time this value will be hold? Till uh, they are assigned certain another value. Okay, जोपर्यंत त्याला दुसरी व्हॅल्यू असाइन नाही होणार आहे तोपर्यंत त्याला आधीची जी व्हॅल्यू आहे ती त्याच्यामध्ये स्टोअर केली जाईल रजिस्टर मध्ये. दे आर नेव्हर कनेक्टेड टू समथिंग, ते कुठल्याही दुसरीकडे कनेक्ट केलेले नसतात, ते फक्त तिथेच यूज केले जातात. They can be used to model latches, then flip-flop, but they do not correspond exactly to these latches and flip-flops. Okay, so they can be used to model these objects, but they are not used, or they do not correspond exactly to the flip-flops, and they shared variables with all their attendant problems. Okay, so this is the two data types that are used in the Verilog. Okay, so again these data types. Okay, so here you can see that what is meant by nets, that is the physical connection between hardware elements. So here suppose these are the input signals, so to connect to the output signals or whatever may be the another module, we use net. Okay, and this registers are, they are also used to store the values. Okay, so now when we can see the difference, now whenever we are looking at these, okay, so this is the net and the register, so you may think that both are equal, but you can see the difference between these two whenever they are disconnected from source. ओके, म्हणजे जिथे तुम्ही इनपुट दिला असेल तिथनं जर तुम्ही डिस्कनेक्ट केलं तर तुमच्या लक्षात येईल की या दोन्हींमध्ये फरक काय आहे. तर नेट काय करणार आहे, नेट फक्त ट्रान्सफर करतं जे काही इनपुट आहे ते आउटपुटला. ओके, म्हणजे दुसरं जिथे तुम्ही कनेक्ट केलाय तिथे तो काय करणार आहे, तर ट्रान्सफर करणार आहे. म्हणजे माझा जर सिग्नल 0 आहे तर 0 फक्त ट्रान्सफर करेल, तो स्टोअर नाही करणार आहे. पण रजिस्टर काय करणार आहे, तर रजिस्टर ती 0 व्हॅल्यू जी आहे ती स्टोअर करून ठेवणार आहे. कधीपर्यंत स्टोअर करणार आहे, जोपर्यंत मी त्याला दुसरं इनपुट देणार नाही. ओके, म्हणजे सपोज मी हे इनपुट जे आहे ते इथे 0 ला कनेक्ट केलं. ओके, आणि तर माझी इथली व्हॅल्यू काय होणार आहे, 0 होणार आहे. दोन्हीकडे पण 0 असेल आउटपुटला, म्हणजे इथून जे ते ट्रान्सफर करणार आहे ती 0 व्हॅल्यू असेल. पण ज्या वेळेस मी इथलं कनेक्शन काढून टाकणार आहे, म्हणजेच मी तो सोर्स डिस्कनेक्ट करणार आहे, त्यावेळेस काय होणार आहे, नेट वरती कुठलीही व्हॅल्यू अवेलेबल असणार नाहीये. So they will switch to high impedance, while as there is no any input here, so this will switch to high impedance, but register will preserve whatever is its earlier value. ओके, म्हणजे जी काही इथे 0 व्हॅल्यू असणार आहे ती प्रिझर्व करणार आहे, किंवा 1 व्हॅल्यू असेल सपोज तर ती 1 व्हॅल्यू स्टोअर करेल. पण नेट वरती 3 असणार आहे तर नेट काय करेल, हाय इम्पीडन्स व्हॅल्यू दाखवेल. ओके, सो दॅट इज द डिफरन्स बिटवीन द नेट्स अँड रजिस्टर. So you always remember that nets are the physical connection between the hardware elements, while registers that stored value between the stored value even if they are disconnected, so they are used to store the values. Now nets are of different types. Okay, so we have discussed about wires and another types of wires in the earlier session. So that is nothing but net. Okay, so nets are of different types, that is a wires or tri, or it may be W and triand, or triand, or W or tri or. That means wire, that means just a connection between the hardware elements. Okay. W and that is also a connection between the hardware elements, but whatever are the devices that are connected to W and wire, so result will be ending, logical ending of that devices. ओके, म्हणजे आता इथे जर तुम्ही बघितलं तर हे दोन डिव्हाइसेस कनेक्ट झालेत इथे, तर या दोन्ही वायर्स इथे जे काही इनपुट अवेलेबल असणार आहे त्याचं एंडिंग होऊन तो रिझल्ट इथे ट्रान्सफर होईल. ओके, त्याचप्रमाणे डब्ल्यू आर साठी पण काय होणार आहे की जेवढे डिव्हाइसेस कनेक्ट आहेत तर त्यांच्यावरती जे काही लॉजिकल इनपुट अवेलेबल असणार आहे त्याचं ऑरिंग ऑपरेशन होणार आहे आणि तो रिझल्ट तुमच्या आउटपुटला अवेलेबल. ओके, सो दॅट इज द वायर मात्र काय करणार आहे, जे लॉजिकल इनपुट अवेलेबल आहे ते तसंच्या तसं तुमच्या आउटपुटला ट्रान्सफर करणार आहे. पण लक्षात ठेवायचं की डब्ल्यू एंड मध्ये काय होणार आहे की तिथे एंडिंग, लॉजिकल एंडिंग ऑपरेशन होईल आणि लॉजिकल डब्ल्यू आर मध्ये काय होणार आहे तर लॉजिकल ऑर ऑपरेशन परफॉर्म. म्हणजे तिथे समजा एखादा आता लॉजिक गेट आहे, अँड गेट आहे आणि त्याला 3 इनपुट आहेत आणि आपण जर ते कनेक्ट केले डब्ल्यू अँडनी तर त्या इनपुटला तिथे जे काही कनेक्ट होणार आहे, म्हणजे तिथे जे काही कनेक्शन जाणार आहेत तर ते काय होणार आहे, लॉजिकल एंडिंग होते. ओके, again there are another types of nets, that is a supply 0, supply 1, then try 0, try 1 and try register. Okay, try means here actually they will be a try state. Okay, so that are the another types of nets there. Okay, so this is about the nets. So in the earlier session we have discussed about this slide, that a wire that is used to represent a physical wire in a circuit. Okay, so that is just a physical connection between the circuit, and that is used for connecting gates or modules, and whatever is the value of wire that can be only read. Okay, that will not be stored. So you have to remember that wire ची जी काही व्हॅल्यू असणार आहे ती फक्त रीड होणार आहे, that will not be stored and it will not be assigned in a function or block. A wire cannot store value, but it is always driven by a continuous assignment statement. Okay? So that means suppose you have a continuous assignment statement, so value of that wire that will change depending on the inputs present at that input ports. Okay? Or by connecting wire to the output of gate and module. So as we have seen this there are certain specific types of wires, that is a W and WR or a tri. Okay, that is a 3-state wires. So here this is the example. Now here you can see that we have the wire that is connected to this port, that is a W and. That means whatever are the inputs that will be connected to this D, that will be through this wire. Okay, which is W and. It is not a simple wire, but it is a W and wire. So we are assigning D, D is equal to A. That means value of A will be assigned to D. Okay, at the same time D we are assigned D is equal to D. Okay, so this value of B will be also assigned to D. That means now we are connecting A and B to D through this W and wire. Okay, so whatever are the inputs present at both these terminals, that will be logical ANDed. Okay, म्हणजेच काय होणार आहे, माझं ए वरती माझं जर इनपुट 1 असेल म्हणजे तिथे लॉजिक लेवल आहे 1, इथे 0 आहे, तर डी ला काय आउटपुट मिळणार आहे, डी ला काय व्हॅल्यू असाइन होणार आहे, तर लॉजिकल एंडिंग ऑफ 1 and 0, दॅट मीन्स 0. ओके, सो या टेबल मध्ये तुम्ही जर बघितलं तर इथे तुमच्या लक्षात येईल की डब्ल्यू एंड मध्ये माझं जर ए वायरला 0 आहे आणि बी ला 1 आहे तर इथे 0 असाइन होईल. ओके, इथे दोन्हीकडे जर 1 असेल तर 1 असाइन होईल. पण सिंपल वायरला काय होणार आहे, जर एका ठिकाणी 0 आहे आणि दुसरीकडे पण 0 आहे तर 0 होईल, पण एका ठिकाणी 0 आहे आणि दुसरीकडे 1 आहे तर या केसमध्ये माझं एक्स व्हॅल्यू असाइन होणार आहे. म्हणजे मी काय, आय कॅनॉट स्पेसिफाय एक्झॅक्ट व्हॅल्यू, सो दॅट विल बी x value that will be assigned there. Okay, so this is again if it is a WR wire, then If at one input there is a 0 and at another it is a 1, then output will have the value that is a 1. Okay, म्हणजे याप्रमाणे असाइनमेंट होतील तिथे. So that is the one of the example for this W and Y. Okay, now we can have wire that is a cable also. Okay, that means we can use this wire as a bus, आणि ते जर तुम्हाला मेन्शन करायचं असेल तर ते कसं करता येईल, wire in the square bracket 9:0 and then identifier that is a A. Okay, and which is ended with a semicolon. Okay, you have to remember that you need to give a semicolon at the end of this statement. So that means this is a cable of 10 wires. Okay, so that is the one of the example for this wire. Okay, so that was about the wire. Now the next data type, that is a register. A register means it is a data object which is holding the value from one procedural assignment to next one, and they are used only in the different function and procedural blocks. Okay, so that means register, they are used to hold the value from one procedural assignment to the next. म्हणजे जोपर्यंत आपण दुसरी ठिकाणी असाइन करत नाहीये तोपर्यंत ते काय करणार आहे, होल्ड करणार आहे. आपण तर त्याला दुसरी व्हॅल्यू असाइन केली तर तो दुसऱ्या व्हॅल्यू घेणार आहे, परत ती होल्ड करेल जोपर्यंत आपण नंतर दुसरी नेक्स्ट व्हॅल्यू असाइन करणार. सो दॅट इज अबाउट द रेजिस्टर. A register is a simple Verilog variable type register and can't imply a physical register. In a multi-bit registers, the data is stored in the form of unsigned numbers and signed extension is not used. So example of this register, that is a REG C colon. So that means it is a single bit register variable. Okay, so whenever we are changing this, assigning this identifier to certain different assignment statement, so it will hold whatever is the value stored at C. Okay. Then we can have vector also there. So register 5 in a square bracket 5:0 gem semicolon. That means it is a vector 6-bit vector. Okay, so 5:0, that means it is a 6-bit vector register. Okay, then register 6:0 D comma E. That means there are two variables. Okay, one is the D and another one that is a E, and both are 7-bit variables. Okay, so this is example of registers. Okay, now as I said earlier that there are 4 values that can be used in a Verilog. Okay, so that means Verilog's nets and registers that hold 4 valued data. Okay, that is a 0 and 1. This is obvious. Okay, any digital circuit that will have the value that is either 0 or logic 1. Okay, so that is obvious. But other than this, it has the another value that is a Z. So that means it is a high impedance value. So output of that undriven tri-state driver, that is assigned as a value Z. And it models case where nothing is setting a wires value. Okay, so whenever we are not setting a wires value, that time it will take as a Z. And then another value that is a X, that models when the simulator can't decide the value. Okay, so in earlier case that we have seen, whenever we are removing, whenever we can't decide what will be the actual value on that wire, so that time it will take as a X value. Okay, so this is the initial state of registers when a wire is being driven to 0 and 1 simultaneously. Okay, so in a earlier state or an earlier slide we have seen whenever we are connecting two wires, two inputs together which are having different values, that is a 0 and 1. So instead of taking any one of these value, it will take as the value that is X, because it cannot decide what should be the value on that wire. So it will take it this value as a X. So the output of gate with Z input, that will be also assigned to X value. So these are the 4 values that are held by nets and register in a Verilog. Now, whenever we are representing this values, okay, so there is a certain format to represent that value. Okay, so suppose in an earlier lecture we have discussed about that there is a length of the syntax for the representation of this value, that is length, then after that radix, then value. Okay, so that means actually there are four data values, that is a binary, hex, octal and decimal. All these types of data that can be represented in Verilog, पण ते रिप्रेझेंट करताना एक टिपिकल फॉर्मॅट आहे की ज्याच्यामध्ये पहिल्यांदा आपण काय रिप्रेझेंट करतो तर त्या व्हॅल्यूची लेंथ काय आहे. ओके, त्याच्यानंतर रॅडिक्स म्हणजे तो कुठल्या टाईपचा आहे ते, आणि त्याच्यानंतर त्याचा रॅडिक्स काय असणार आहे आणि त्याच्यानंतर ती व्हॅल्यू काय असणार. ओके, हे आपण रिप्रेझेंट करतो. म्हणजे जर बायनरी आहे तर इथे आता एक एक्झाम्पल दिलंय की 6. 6 म्हणजे काय आहे की त्याच्यामध्ये 6 बिट्स असणार आहेत, त्याची लेंथ काय असणार आहे 6 बिट इतकी असणार आहे. आणि त्याच्यानंतर तो काय आहे नंबर बायनरी आहे तर त्याच्यासाठी बी अँड देन नंबर दॅट इज अ whatever is the number. So here it is a number that is a 100 101. Okay, so this is the representation of binary number. Okay, now suppose it is a hexadecimal number. So now here it is a length of that number in a binary representation. Okay, so remember that this is the value that will represent length in a binary representation. So 6, then apostrophe, then radix, that is a h as it is a hexadecimal number, and then after that number. Okay, 25. Now whenever we are going to, this is a hexadecimal number, but whenever we are going to represent this number in a binary format, it is going to be represented as a 6-bit number. Okay, so remember that this number will represent a binary for length. Okay, so now there are certain keywords that are used in the Verilog. One is the input, then output, and in out. Now, what is these keywords? These are the ports. Okay, म्हणजे ज्याप्रमाणे तुम्ही VHDL मध्ये ports, input, output आणि in out port म्हणता, त्याचप्रमाणे Verilog मध्ये ports साठी कुठले keywords वापरतात तर input port, then output and in out port. Okay, so input port that means इट इज फॉर द इनपुट पर्पज. म्हणजे तो तुम्ही कुठे आउटपुट साठी नाही यूज करणार आहे, तिथे फक्त इनपुट येणार आहे. आउटपुट दॅट मीन्स इट इज युज्ड फॉर द आउटपुट पर्पज, अँड देन बाय डायरेक्शनल दॅट मीन्स इट कॅन बी युज्ड एज फॉर द इनपुट एज वेल एज आउटपुट. आता यामध्ये मग काय असणार आहे की इनपुट पोर्ट जे आहे ते फक्त आणि फक्त वायर टाईपचे असेल. ओके, कारण तो काय करतो फक्त डेटा ट्रान्सफर करतो. सो इनपुट पोर्ट एज वेल एज इन आउट पोर्ट्स दे आर ऑफ wire type, but output ports can be configured as a wire or register, or it can be WAN, WR or try. यातलं कुठलंही असेल, पण इनपुट पोर्ट आणि इन आउट पोर्ट हे काय असणार आहेत फक्त वायर टाईपचे असणार आहेत. आणि ज्यावेळेस कुठलाही टाईप मेन्शन केला नसणार आहे तेव्हा बाय डिफॉल्ट टाईप हा वायर असतो. म्हणजे जिथे नेट कनेक्शन आहे तिथे बाय डिफॉल्ट वायर जर कुठलाही टाईप मेन्शन केला नसेल तर तो वायर टाईप असेल. Otherwise it will be a mention for input port आणि in out port साठी wire, आणि output port साठी मग तो wire असेल, register असेल, WAN, WR or try. Okay, anything will be there. Okay, so example for this is input C. Okay, so this is the identifier port, that is a, this is the input port, that means this is actually input where wire is used. Okay, output A comma B, that means there are two outputs where again wire is used. Now in a earlier session we have discussed about how to comment in a Verilog. So here two backslashes, that means it is a single line comment. Okay, so this is the comment that is used in a Verilog language. Then output a comma b, that means again this is shown here or expressed here using a comment, that is with two backslashes and then sentence. That is a two outputs where wire is used. Now here there is a one more example, output in a square bracket 2 colon 0 d. That means this is the output, and it is a 3-bit output because here we are mentioning its length. Okay, so here it is a 2 colon 0. Now this is represented in a multi-line comment. So this comment is given in a multi-line format. So it is a backslash star and then whatever. इथे तुम्ही आता बघू शकता की इथे माझं 2 लाईन मध्ये कमेंट आहे, तर मग मी ती या फॉर्मॅट मध्ये घेऊ शकते आणि त्याच्यामध्ये रिप्रेझेंट करते. ओके, सो दिस इज अ 3-bit output. And now if you want to declare its type, so you need to use a separate statement for that. Then register 1 colon 0 a, so that means it is a port. Here now actually we have declared that this a is the output port. So now here we are declaring that it is a register which is of 2-bit. Okay, so this a is the 2-bit register. So that means we are using a separate statement for the declaration of a port. Now in a Verilog we are using integers. Okay, now for what purpose these integers are used? It is a general purpose variables. They are used mainly in loops. Then indices can be used as a constants and parameters. Okay? And remember that these integers, they are of the register type data. They stored data in assigned numbers, whereas explicitly declared register types store them as an unsigned data. Now, if the integer is not defined at the time of compiling, then default size would be 32 bits. Okay? So, if the size is not mentioned, then it can be taken as a 32-bit integer. If an integer holds a constant, the synthesizer adjusts them to the minimum width needed at the time of compilation. So, the example of this integer, that is an integer and c. Okay? So that means as here size is not mentioned, that means it is a 32-bit. Okay. Now assign c is equal to 63. Okay, so here this constant value that is assigned to this a. So that means as 63, that is a 7-bit variable, 7-bit. So it will take as the 7-bit variable. Now in earlier slides, we discussed about this supply 0 and supply 1. These are the another types of nets. Okay. So now what is meant by supply 0? Supply 0, that means the wires which are tied to logic 0. म्हणजेच काय आहे की त्या ग्राउंडला कनेक्ट केलेल्या ज्या वायर्स आहेत त्याला आपण सप्लाय 0 नेट्स म्हणतो. आणि सप्लाय 1 म्हणजे काय आहे तर ज्या लॉजिक 1 ला किंवा पॉवरला ज्या कनेक्ट केलेल्या वायर्स आहेत, दॅट मीन्स अ सप्लाय 1. ओके, म्हणजे ज्या सगळ्या वायर्स आपण ग्राउंडला कनेक्ट करणार आहेत दॅट आर द सप्लाय 0 नेट्स, अँड those wires which we are going to connect to power or the VCC supplies or the logic 1 supply, that are the supply 1 lines. Okay, so here these are the examples for supply 1 and supply 0. Now one more thing, that is a time. Okay, so how to mention time in a Verilog? So time is a 64-bit quantity that can be used in a conjunction with $time system task to hold simulation time. Time is not supported for synthesis. Okay, so remember that it is not supported for synthesis and hence is used only for simulation purpose. Okay, so whenever we are doing simulation, that time only time is used. Otherwise, for synthesis, this is not used because it is not supported there. Then parameter is defining a constant where which can be set when you use a module which follows customization of module during the instantiation. So the example of this is a parameter, then add, which is equal to 3 bit length. Okay, so b, that means binary number 0 1 0. Okay, and sub, that is equal to 2 asterisk apostrophe b 1 1. Okay, so that means it is a 2 bit number. So parameter, again the another parameter, that is a n is equal to 3. So parameter, there is one more example, that is a parameter 2 colon 0 param 2. So okay, that means this is a 3 bit parameter, and it is represented as a 3 apostrophe b1 1 0. That means it is a 3 bit binary number which is the having value, that is a 1 1 0. Okay. So these are the examples of parameter. Now the operators that are used in the Verilog, that are arithmetic operators that are used in the Verilog, which are used to perform arithmetic operations, that are plus and minus, that are used for either unary or binary operators, and the operations which are included in arithmetic operations, that are plus, that is addition, then subtraction, then star for multiplication, backslash for division, and percentile for modulus. Okay, so plus sign, that is used for addition purpose, minus, that is used for subtraction, star for multiplication, backslash, that is for division, and percentile for modulus. Okay. So these are the different operators, arithmetic operators, that are used in Verilog. Okay. So suppose we have the example here, that is a parameter v, that is equal to 5. That means we are assigning value 5 to the v. Then we have the register, which is a 4 bit b, d, h, and I, and count. Okay, so all these are the 4 bit registers. So h is equal to b plus d. So that means what it will do? It will add whatever is the value of b and d, and it will assign that value, a result of that, to h. I is equal to d minus v. That means here it will subtract this value from d. Okay, then this count, that is equal to count plus 1 percentile 16. That means it can count 0 through 15. Okay, so that means actually it will take the modulus value of this. Okay, now if we consider rational operators, so these are relational operators. These are for equal to. So for equal to, we use the sign, that is a equal to. Then exclamatory mark equal to, that means it is not equal to. Greater than, then greater than equal to, less than, and less than equal to. So these are the relational operators that are used in the Verilog. Okay, so what these relational operators do? They compare two operands and return to the result, that is a single bit. Okay, so that means it will be, the result of that will be either 1 or 0. Okay, so here suppose we have two registers value. Okay, that is a minus 3 d001 and that is equal to 3 d111. So these are some of the examples of these relational operators. Now, the bitwise operators in a Verilog, that are AND operator, then bitwise OR. For that we use a symbol, that is a vertical line, then tilde for bitwise, not exponential mark for bitwise XOR, and tilde and exponential mark, or exponential mark and tilde for bitwise XNOR operation. Okay. So here these bitwise operators that will perform the operation bit by bit comparison between two operands. Okay. So प्रत्येक बिटचं तिथे comparison होईल आणि मग तुमचा resultant येणार आहे, and that will be the result for your operator. So these are the examples. I'm not going in much detail about this because already we have discussed about this. Now the logical operators. So here logical operators that are again bitwise operators and that are used only for single bit operands, and they will return to a single bit value because they are just checking the logic between this. So it is a 0 or 1, and they can work on integers or group of bits expression and treat all non-zero values as 1. So this logical operators that are exclamatory mark for logical not, then and ampersand for logical and two vertical lines for logical or. For reduction operators, these are unary form of the bitwise operators, and they are ampersand for reduction and then vertical line for reduction or, tilde and ampersand for reduction and tilde and vertical line for reduction or, then exponential mark for reduction XOR, and tilde and exponential mark or exponential mark and tilde, that is for exponential NOR, XNOR operation.
मॅम हे रिडक्शन ऑपरेटर कुठे यूज करतो आपण?
ऍक्च्युली दे आर युज फॉर युनरी फॉर्म ऑफ बिट. जेव्हा युनरी फॉर्म असेल ना त्यावेळेस आपण तिथे युज करतो. मोस्टली आपण खरं तर म्हणजे लॉजिकल ऑपरेटर्स किंवा बिटवाइज ऑपरेटर्स यूज करतो. दीज आर whenever we want to get we are using a unary form of operator, that time only we use this. Okay. I think we are running behind time, so let us discuss about these another types in the next lecture. So for today we will stop here. Um, if you have doubts regarding this, you can ask. Okay, this is just a theory, so I'm going a little bit fast. But तुम्हाला जर काही लक्षात येत नसेल किंवा काही प्रॉब्लेम आहे असं वाटतं तर तुम्ही तिथेच मध्ये विचारू शकता. So for today we will stop here. Okay, remember